Hello everyone, my name is Aarohi and welcome back to my channel. So guys, today we are going to talk about YOLO26, which is a latest object detection model released by Ultralytics. And according to the official paper and documentation, YOLO26 is specially optimized for edge development. Means you can use YOLO26 efficiently on edge devices. And this paper highlights one very important issue, which is that recent YOLO models, they achieve excellent accuracy, but they became harder and harder to deploy, especially on edge devices and on low power devices. So the main focus of YOLO26 is optimization rather than just pushing around the accuracy numbers. And guys, instead of introducing a completely new architecture, they improved the current object detection pipeline. Means how the model is getting trained, they improved this. Then how predictions are assigned during training, they did improvements in this part also. And then they did some improvements in multi-scale features, how multi-scale features are combined, right? So all these things we are going to discuss today, and after that I'll show you the practical implementation also. Now let's understand what is the real motivation behind these changes. So whenever we work on real world object detection applications, so we face many problems. One of the major issue is limited memory, and edge devices like Jetson boards, mobile phones, or embedded systems, they simply cannot handle very large models, right? And another major issue is latency. Even if a model is accurate, it may be too slow when we run it on a low power hardware. Means high accuracy alone is not enough. A useful model must run fast, it should use limited memory, and it should work reliably on edge devices. But if we look at older YOLO versions, their main focus was on improving the map values and FPS, and they tried to achieve better benchmark scores on academic datasets. And in most cases, comparisons were done by using the map values, and real world deployment concerns like how to export model, runtime stability, or hardware constraint, these kind of issues were handled after the model was already released. But we all know that in real applications, deployment is the hardest part. High accuracy alone does not solve real deployment problems. So this was the problem statement which Ultralytics focused on while building this YOLO26. And the main goal of YOLO26 is to make the object detection efficient, practical, and reliable on edge devices and on low power devices. And to achieve this, YOLO26 introduced several design level and several training level optimizations. Now we will discuss all of them one by one. First, let's see the paper. Let me show you what all changes they have mentioned, and then we will discuss them. So just scroll down and we will go to the section where they have mentioned this architectural enhancements. So they have mentioned few improvements in this section. Let's discuss that. So the first improvement is removal of distribution focal loss. What it is, why they did changes in it, that part we will discuss in some time. And the second change is improvement is end-to-end NMS-free inference. And after that, the next change is this progressive loss and this STAL. So this part also we are going to discuss in some time. And then the fourth change is this, where they combined two optimizers. So these are the four things which we are going to discuss now. And these are the four major improvements which they introduced in their paper. So let's start with this end-to-end NMS-free inference. This improvement is basically related to how duplicate predictions are handled. And if you have worked with object detection, then most probably you already know about this NMS non-max suppression. So in earlier YOLO models, the model used to predict many overlapping bounding boxes for objects, and then a separate post-processing step called NMS was used to remove the duplicate boxes. And NMS works well, but the problem is extra computation, extra complexity, and unpredictable inference time, because for every image, NMS has to process so many boxes, which is computationally expensive, and especially on edge devices. So YOLO26 stopped using this NMS process. Means instead of fixing the overlapping bounding boxes or duplicate bounding boxes after the prediction, the model is trained to avoid producing too many duplicate boxes, too many duplicate bounding boxes in the first place. And for that, YOLO26 learns during training only that which predictions should survive and which predictions should be suppressed. And if this step is removed, then automatically inference become faster, which is extremely important for real time and edge development. Now, another major improvement is that YOLO26 completely moves away from anchor boxes. And guys, if you remember, in older YOLO versions, anchor boxes were used as a starting point. So anchor boxes are predefined rectangles of different shapes and sizes. And these anchor boxes had to be manually designed. And if the anchor boxes did not match with the object sizes which we have used in our dataset, then performance could drop. So that's why YOLO26 use a fully anchor-free approach. Means instead of starting from predefined box shapes, the model directly predicts the object location and size. And this simplifies the training process. This makes the model more robust across different datasets, because earlier you need to take care that your dataset, the objects which are there in your dataset, should work well with the anchor boxes. But with the removal of anchor boxes process, now the training become more robust and you can work with different datasets easily. This simplifies the training process, right? So this was the second improvement. Now we know about this section. Let's talk about the next improvement. So scroll down. So this is basically a training level improvement. So YOLO26 introduced two important techniques. First one is this PROG-loss, which is progressive loss balancing. And the second one is this, which means small target aware label assignment. Now let's understand both of them one by one, and we are starting with this progressive loss. So guys, whenever we work in object detection, the model learns three different losses, three different things. First one is classification loss. Classification simply means what object is this? So that loss we calculate. Then second loss is localization loss. Localization loss simply means how accurate is the bounding box. And then objectness loss. Objectness loss simply means is there an object or not. And in older YOLO models, one loss could dominate the other losses. And this makes the training very unstable. And progressive loss fixed this problem by balancing the classification, localization, and objectness losses, making sure that single loss should not dominate the others. And because of this, now the training is more stable, model converge better, and generalization is improved. Now let's talk about the second one, which is small target aware label assignment. Guys, we all know that small object detection is one of the hardest problem in computer vision, because small objects occupy very few pixels and they are easily occluded. So this STAL, this improves the label assignment during training. Now what is label assignment? Label assignment simply means deciding which predicted boxes are positive and which predicted boxes are negative. And older YOLO models, sometimes they struggled when objects were very small or when multiple objects were close to each other, because this caused confusion and unstable training. Now let's see how this STAL handle this problem. So this STAL, this explicitly prioritize the small objects, which improves the matching between the predictions and the tiny targets. It basically makes sure that small objects contribute meaningful gradients. So even if an object is tiny or partially hidden or there is a cluttered scene, the model still learns about it properly. So this improves the small object accuracy without increasing the architectural complexity. So this is what this section is about. Now let's talk about this section. So from here, we can see that this is an optimizer. Now what is an optimizer? So optimizer decides how the model update its weight during training. And even with a good architecture, if you are using a poor optimizer, it can slow down the training. It can make the model unstable. This MuSGD. So this is a hybrid optimizer which combines two optimizers. First one is SGD, and which it is using for stability and generalization. And the second one is Muon style technique, which is inspired by a large language model training. So as compared to the older YOLO versions, this MuSGD, this converges faster and it makes the training more predictable. Even with the few epochs, you can get good results. So this reduces the training cost and development cost. Why? Because now we are training the model for lesser epochs. This is what they have discussed in this part. And now let's go above. We discussed this part. We have discussed this. And then we have discussed this part also. Now only this part is left. Now let's talk about this one, removal of distribution focal loss. So guys, before understanding removal of distribution focal loss, let's understand what this distribution focal loss is, what it does, and why they removed it. So the older YOLO models, they used to predict the probability distribution for box coordinates instead of direct values. For example, the model predicts something like width is probably 48 and 20% probability. Then another value is width is probably 49 and the probability for this value is 30%, and then the width is probably 50, 40% probability for this, and width is probably 51 and the 10% probability for this. So this is called probability distribution, and DFL was used to train these probability distributions. And after the training, then the other task is to convert them back into the final box values. And guys, why the older YOLO versions use this technique? Because predicting a distribution is more accurate than predicting a single number. So yes, we can say that accuracy was improved a little bit, but it also added extra computation. How? Because predicting distribution means more outputs, more maths, which means slower inference. And after the prediction, model is again decoding the distribution, which is again an extra step during inference. So YOLO26 removed this DFL step completely, and it predicted the value of 4 values of the boxes x, y, width and height directly. So that means there is no distribution, there is no decoding step, no extra complexity, no extra computation. And most important guys, accuracy didn't drop because this STAL, this improves the supervision, this progressive loss stabilizes the training, and the optimizer which they used over here, this improves the convergence. And guys, why this matters in real life? Because in real applications, model run on edge devices and memory is limited, and speed matters more as compared to the tiny accuracy gains, right? So by removing this DFL, YOLO26 gets faster inference, low memory usage, and it is easier to export it to other formats, and we will also get stable runtime on edge devices. So guys, now we know what YOLO26 is. Now let's see how to use this model. But guys, before that, let me show you this, that with YOLO26 we can perform object detection, instant segmentation, key point detection, oriented bounding box detection, and classification. And today I'm going to show you all these tasks. We will use pre-trained model first. Pre-trained model means the model which is already trained on some data set, and we will load that pre-trained model and we will perform predictions on unseen dataset. We will give input to it, we will give images and videos to it, and we will see how this YOLO26 pre-trained model works on it. And in my next video, I'll show you how to work with a custom dataset. And guys, to run today's code, the only prerequisite is that Python should be installed, and after that you will only install one package, which is Ultralytics. Here it is, you can see in their GitHub repo also, pip install Ultralytics. So this is the only package which you need to install. So install Python. If you have Python already installed, then run this command and you will have Ultralytics package installed, and this is the only package which is needed to run our today's code. So let's open VS Code, Visual Studio Code. Here we will work. First, let's open the folder where we want to work. So right now we are in C drive. Let's enter in E drive. And guys, in E drive, I have one folder, a blank folder with the name of YOLO26 demo. We will enter in that folder. YOLO26 demo. Okay, let me show you this folder over here also. So see, this is the folder. Here we are going to work. So guys, in my case, I have a separate Python environment. So I activated that environment and I will work under that environment. And in your case, this step is not mandatory, but this is recommended. Whenever you try something new, always try to work in a separate environment. But for now, if you don't have a Python environment, just work in the base Python. So let me show you the Python version I'm having. This is the Python version and I have already installed Ultralytics. So I'm just showing you the version which I have. See, this is the Ultralytics version and this is the Python version. Now let's open the folder over here. So this is the folder. I'm opening this folder. So now we are in this folder. Right now this folder is empty. So we are going to create one Python file and in that file we will work. So just right click, new file, and I've given a name demo.py. So this is where we are going to write the code and we will run the code over here. So first step is to import the package. So we are importing the YOLO from Ultralytics package and then we are loading the pre-trained model. So we want to load which model? The object detection model. So guys, I have told you already that there are different tasks, computer vision tasks, which we can perform using YOLO26, like image segmentation, object detection, oriented bounding boxes, or image classification, or key point detection. So first we are starting with the object detection task, and this is the name of object detection pre-trained model, which was trained on COCO dataset. And guys, for every task, like for object detection, there are 5 different variants of the model. And for image classification, YOLO26 have 5 variants. So like this, for every computer vision task, YOLO26 have 5 different variants. 5 different variants simply means the difference in their size. There is a difference in their size. This N is the smallest model, and then the next one is S, and then M, L, and XL. So here I'm showing you how to use the smallest model. In the same way, you can use any model. So we loaded the pre-trained object detection YOLO26 model. Now we want to use it to perform predictions. To do the inference, we want to use this model. And let's say we want to do the inference on this image. So 1.jpg image, which is in assets folder. So right now in our YOLO26 demo folder, we don't have anything. So we will create one folder with the name of assets, and in that we will place this image, and then we will come here and run this script again. So let's open the YOLO26 demo folder. So this is my YOLO26 demo folder. Right now this is the demo.py file which I'm showing you. Let's create a folder with the name of assets and let's place this image in it. Now let's go back here and run python demo.py. See, when you executed this code over here, the model is loaded and then task is completed and the results are stored at this location. Means in runs folder, we are going to have detect folder, and inside that we are going to have predict folder. There we will get the predictions. But before that, before seeing the prediction, let me show you the input image. So this is the input image, and after inference in runs folder, detect, predict, here is the output. See, it is detecting all the classes: chair, class, cup, dining table, person. It is detecting all the classes. Now let's suppose you have a folder and inside that folder you have multiple images and you want to perform the predictions. You want to do inference on all those images at once. So I'm pasting one folder over here with the name of images, imgs, and inside that we have 2 images. So let's see how to do detection on a folder. So you will just write the assets. Okay, let me just copy it and let me comment this one. And in assets we have folder with the name of images. Okay, this save true You need to write this, then only you will see the runs folder in your current working directory where you will see all the output images. Okay, so save it and run it again. See, this time output is stored at this location. Let's go to this predict to folder. See, runs, detect, predict to. See, we have two images. This one.jpg is the same image which I've shown you earlier, and this is the second image, right? So this is how you can work with multiple images. Now, if you want to perform the object detection on a video, how to do that? Let's see that. So let's paste one video in assets folder and we will perform testing on it. Let's comment this and let's just copy it from here only. And in assets, we have a video with the name of skating.mp4. Save it and run the code. See, all the frames are getting processed and output is stored at this location, predict3 folder. Let's open predict3 folder. See, objects are getting detected. So guys, this is how you can work on a video. So this is how you use YOLO26 object detection model. Now let's see the next model. Scroll down. See, these are the different models. Right now we used this model, right? And these are the different four variants. Now YOLO26-seg, it means segmentation model. Hyphen pose means key point detection model. Hyphen OBB means oriented object detection, and hyphen class means CLS means classification model. So you can pick any model from here. So let's say we want to pick this model for segmentation task. So I copied it from here, the name, and here let's paste this name and let's run it on same video. Right now, let's clear it and run the code again. This time it will perform segmentation and this model will be downloaded first. Okay, let's just see. See, this model is also downloaded because this is a segmentation model. Earlier we downloaded the detection model. Task completed and output is stored in runs folder, inside that segment folder, and then predict folder. So runs, segment, predict, and this is here we can see. See, the task is successful, right? So this is how you can perform image segmentation. So you can perform image segmentation on video, and you can perform image segmentation on multiple videos or images which are there in the single folder, and you can perform image segmentation on single image like this. Now let's see the next model. Now this time let's use this model. So just copy the model from here, the name only, and then paste the model name here, and then provide the input to it. So I want to perform pose detection on this video only. Save it and then run. So this time this model will be downloaded in our current directory. See here, right? And once the task is done, in runs folder you will see this folder, and inside that predict folder. So runs folder, this is the output. Let's open it. Runs, Pose, predict, and this is the output. See, key points are getting detected. So this model is also working fine. Now let's see which is the next model. And this time we are using a CLS, classification model. And here let's change the source. Let's give different input this time. So let's paste one image in our folder. Let's paste one image in our assets folder. This is the image H. The name of the image is h.jpg. So h.jpg. Save it and run the code again. See, this model is downloaded and then output is stored at this location. Let's go to the location, classify, predict, and this is the output. See what is this sorrel means? Sorrel is basically a reddish brown horse. So 91% probability our model is giving that this image belongs to this class, and only 2% probability that it belongs to this class. So we will see the top 5 probabilities over here. And guys, this is how classification model works. So the link of this code is given in description section. You can get this code from there. And I hope my video is helpful. And guys, if you like my content, please like, share and subscribe my channel. And in my next video, I'll show you how to work with a custom dataset.